Hi, this is Koiro with a new video for you. I kind of got sidetracked when I was doing some work on my Spectrum Leningrad clone. And this is a project that I've been searching for a solution for some time now. I have until this time used my trusty old Commodore 64s for testing DRAM chips. When I was doing the testing on the Leningrad board, I thought that it would be better to have a standalone solution for DRAM testing, which brings me to this device here. I started up Google and just entered 4164 DRAM tester, as the chips that was used in the Leningrad is the Russian version of 4164. And there was quite a few hits, and I remember doing this a few years back, and I couldn't find anything that was related to much of a do-it-yourself products. There was some more expensive options, there was some huge used options on eBay and so on. But now the field actually seems to be circling around something that's Arduino based. And I started to dig into this a bit further and found some pictures and found some other articles. And this one was the one that caught my attention, and I think this is close to the original circuit and the original author of this. And there are some notices on these web pages about versions of software and versions of hardware and so on. And there was also some failed attempts for this software where they had some people writing in and telling them that this was not doing a proper test. But anyway, when you are testing DRAM, you have to remember that a DRAM is almost like a capacitor. You feed a charge into a cell and you have to refresh it every so often. And I'm not sure how good this really is to have a really good sustainability test on one of these chips. For as far as I can see, it's only testing one cell at a time and recharging the same cell a couple of times and reading back the contents to see if they are still there. And that might be a good test, but there are some issues with DRAM chips where you have, when all the cells in one piece of the chip is charged, you can get some overflow and other stuff. And they also say it in the test that this tester is only give a certain result if it say the chip is failing. And that's quite a good option for me, because if the chip is failing, I know at once that it's defect, and if it's kind of working, that be something I can work with. And if I am in doubt, I can really do the testing in a Commodore 64 with the test cartridge inserted. But as you can see, they have really done a really good and simple job with this design, as they feed it with the output-input lines of the Arduino, and they use the analog outputs to feed the address bus, and they read back and write to pin 8 here, that is the data bus. And they also do the CAS and chip select and RAS signals from the bus. And the test is built so that the Arduino will count through each address 4 times and write pattern into the chip and read it back. As there is just one data bit on this chip, you could either test it in a sequence that's 1 0 1 0 1 0 or whatnot. So it's probably a good enough test to give you some pointer if this is good or bad. And they also have included an options to test the 41256 kind of chip, and that is exactly the same design. The smaller chip doesn't use this A8 line. And as it's selectable by a jumper, you just pull pin 10 high if you select 4164, and if it's low, you are testing a 41256. And of course, if you have this on 4164 and you are testing 41256, you will still test the first 64K of the chip. And actually, if you leave this off and have this in 41256 mode, you will test the 4164 several times, as it will read the same cells twice if it doesn't get any address bit here, so that you will select more addresses because the addresses is not really there. That's what we call mirroring when we have memory decoding. If you don't take this bit into account, you will only have the lower memory pointed to several times. And the test is so that it will blink green while you are testing, and it will light up red at once it finds a fault. And since this chip is based on Arduino, they have also utilitized the serial output of the Arduino so that you will get the feedback into your Arduino software if you have put this up for serial monitoring. So I think this is actually quite the neat kit, and the cost for this is extremely low. And because of the simple layout where they have tried to route the outputs and inputs to the closest part of the gates, they actually made the layout quite simple. And as you can see here, they have laid out this on experimental Arduino hat. I was going for a somewhat similar design. I don't have any Arduino development boards like this, so I opted to start just with a blank test PCB. And I didn't film any of the soldering, as this was done on a site where I don't have access to any filming equipment, but I will show you a short rundown of what I have done and the result. Yes, and as you can see from the picture we started out with, I have made this design as close to the original clippings from the web as possible. And I started out with this square piece of board, and I found these pins here, and this is actually something that's really old, because this is pins that was made back in the day when they used wire wrappings to do prototyping of boards, and I have a whole box full of those pins, and they have the added benefit of being so long that it doesn't matter if the pin spacing is not totally correct. And for the Arduino headers, you have these headers that stands close to each other, but they are not the standard 2.54 distance between them. So I just bent the pins like this to make it fit. And on this side I also just placed it like this. But this is an easy job to separate these pins. And as I said with the layout, I started with placing these pins, of course. And when I have done that, I just started to route each pin to the appropriate pin on the board. And when I route on this board, I just solder a small wire on top of the pins like this. And the whole design here is actually done with just two wires that cross each other. And I could have avoided that too, because I have the space here to route around this way. And if I have been a bit more forward thinking, I would have done that too, where I have this ground wire routed up in the air. It would be possible to take this out this way if I have been taking that into considerations when I lay out the board. So this is the exact same design that is shown on that schematic we looked into, and I just used a SIF socket, and I have two LEDs, and these are unicolor LEDs. I have just used the green and the red part on this. So this is the exact same design, and this is my copy. It's a Geek Crate copy of an Arduino, and I've been using it for several experiments, and it's quite okay. It's not the best quality. It's a bit crooked, and the soldering on this is not very good, but it works like an ordinary Arduino, and I've never had any issues with it. And I built this now to have a device to test the Russian 4164s that was for the Leningrad project, and I actually got myself a surprise as I did this. Sorry for the sharp lightning in the picture of this. I actually got myself a surprise, for it seems like every one of these chips is actually working. And when I was testing the Leningrad kit, I actually had some of the DRAM chips was actually quite hot. It was probably the DRAM chips that was used to give screen output that got hot. So it's probably a good explanation, and they was not overly hot. They was just hotter than the other chips. A test in this takes about 80 seconds when you have it in 4164 mode, and as you can see, this tested green and was okay, and that's actually the case for every one of my Russian chips. So I'm quite happy with that. I also started to test some other chips, and I made this video a while back ago about counterfeit 4164 chips, and this is actually one of the chips that I bought in that batch. So let's see what happens with this one. As we can see, it lights up red immediately, and this is actually the case with every one of the chips that was in that shipment, where I got that suspicious looking 14-pin 4164 memory chip. And this is a chip from the same vendor. It seems it's the same markings on the chip, but this is actually a genuine chip that I had. I pulled this out from a memory board from an old IBM computer just to test. It was the only other chip I had from the same, with the same logo on, and this completes the test. So it's nothing about the make of the chips that makes them fail. It was that every chip I got in that shipment with the fake chip, every one of them failed the test. And for those of you who know your history, it was all kinds of these chips, and this is actually an 8264. That is about the same chip as a 4164. It had a different make, and it also had some different characteristics, but this also tests good as a 4164. So I'm quite happy with this design, and it's easy and it's cheap, and if I can trust these results, I will be very happy with this, because testing DRAM chips has always been an issue with me. And back in the day, I had this old EEPROM and chip tester that actually could test DRAM memory chips. But you have to buy a very expensive pad for each type of chip. And I had this tester for the 4164 back in the day, but that actually got sold off many years ago, and I'm quite happy to have something with a similar functionality for almost no cost at all. And if you want some more details about how I made this, or if you want to have some other pointers, just leave a comment below and I will help out in any way I can about this. So this ends this short video. Thanks for watching, and I hope to see you again in another video quite soon. And please hit subscribe if you want to be notified when I post another video.